Oh, hi. You must be here because you want to know the difference between a liquid spore syringe culture and a liquid culture. Well, here's the difference. All of these mushrooms out here that are currently hiding from me are either preparing or are already done to create in creating spores. Those spores aren't meant to land on some petri dish that give it a super advantage to grow or anything like that. They fall out here in the wildest of conditions. I mean, the rain, the drought, they land on the dirt, they land on the duff, anything leaf litter and wood. Well, I mean, when those spores land in the right conditions, what happens is the spores germinate. They start pushing out a little tendril. The little tendril goes off in search of other little tendrils like itself, genetically compatible enough to be able to fuse together and create a mycelium with two full sets of genes at that point. It's kind of like a sperm and an egg in that each of those halves, starting from a single spore, contains half of the genetics that actually are needed to form a complete organism. It's called haploid versus diploid. Haploid being when a single spore produces a little bit of mycelial network, but it's only half of the genetics and it hasn't fused with another genetically compatible hypha from another germinated spore. So when those two do fuse, what you end up with is a little colony of fungi that is going through all these enzymatic combinations due to the genetic information that it has, and it is trying all these different chemicals like a field laboratory, trying to find out whatever's going to digest on the substrate that it landed on, because it's a do or die situation. The fungus must either latch onto food, begin decomposing it and getting in there and inhabit it, or it is going to die from any number of factors. UV, heat, drought, cold, any number of things could cause the death of a delicate little fungus like that that's just fused together. So here you have this set of two spores that have germinated and fused together and have this genetically distinct organism that is completely unlike any other fusion of any other two spores that's happening anywhere around it, even from the same mushroom. Even from the same mushroom. That's right. So, those two, while they're at a small disadvantage in that they have to, start from literally the ground up, the very first brick, and build themselves up into a network that covers the area they're going to cover and colonize, and then eventually produce another mushroom that produces spores to complete the life cycle. The liquid culture syringes that you purchase from cultivators online, liquid culture syringes are made from liquid mycelium, that is from the diploid organism, with two sets of genes. That's two spores that have germinated, fused together, were compatible, and form a single colony. And at that point, it begins, as I said, trying to find all the various enzymatic, genetic combinations for the hypha at the leading edges of the colony to try to keep spreading at all costs, eat everything in the way, and do it as efficiently as possible. Well, when a cultivator takes a small section from the edge of the leading edge of that colony, as it's grown out some, what you have is you've compressed what you have is you've taken the total genetics, which are all expressed all around the ring of the culture and growing in all different directions, so that two bits from two different sides of the culture would not genetically recognize themselves, but would in fact form two different colonies. What you want to do is take the nicest looking rhizomorphic section of that fungus growing on your agar and go ahead and take a small sample of that and from the leading edge and go ahead and move that to a new home on new agar. From there, go ahead and let it colonize, under sterile conditions, of course. You don't want anything else to get in there because agar will multiply anything by 1,000 that gets in there. Spores, bacteria, other fungi. So keeping it completely clean, you've now got one sample that's a generation away from the original sample, right? Sometimes in a lot of species that's enough to get a fungus that will grow and be essentially genetically homogeneous all the way around, so that if you took another sample off of that, it would form a colony that would eventually, form back in with the rest of the second generation colony. So they are genetically compatible. There's a spider that's about to crawl over the phone. Is it going to crawl over the phone? No, it changed direction. Cell phone's in the forest. So with this liquid mycelium, what you have is you've got a genetic isolate, a genetic culture isolate. So it's the only thing growing in the liquid culture, and it is genetically identical to all the little bits of fragments of fungi floating around in the liquid culture. It's just one mushroom sort of shredded up, essentially. Not literally, it's just that all of that fungal network is all genetically identical and floating around within the little barrel of your liquid culture syringe or your jar. So, multi-spore isolate, you're going to end up with, if you inject some sort of substrate bag, the proper substrate for your mushroom, with a spore syringe, what you're going to end up is a concentration of little spores all trying to fuse together and mate. And then as they grow, they're going to form genetically distinct colonies going up the sides of your bag, segmenting your block into different sections and producing less than the total potential of your output, due to the fact that you've got all these distinct genetic individuals within one block that are fighting for control of the substrate. Okay, and that is what happens when you start a block from a multi-spore sample as opposed to a liquid culture, genetically homogeneous sample of culture that you normally get in a liquid culture syringe. Once the fungus organism has been separated once or twice, or however many times it's necessary for it to get very even rhizomorphic growth that looks the same across the entire organism, then at that point it's ready. You can take a sample of that and put that into your prepared liquid culture medium. Of course, in a sterile manner. Always have to keep this azenic, meaning that the fungus is the only thing growing in there. Nothing else gets in. And usually people do this in a laminar flow hood or, still air boxed. You could get away with that definitely too. But that is how liquid culture is created. You start from a very clean sample that is genetically separated from the rest of the chaotic, genetically dynamic and diverse organism that's growing at all edges, pushing out genetic expression in the material that's meant to eat and find the perfect combination of enzymes to be able to just go through that substrate. So instead of finding all that combinatorial optimization in the genetics, what you've got a single culture that's already ready to play together in your liquid mycelium, your liquid culture syringe, okay? And that's the diploid organism that's already fused together and isolated, genetically homogeneous throughout the entire liquid culture. When you inject that into your block, what happens is the whole block grows through with one type of fungus, one genetically distinct individual that's not fighting against itself. So you get optimum growth, you get optimum harvest. The problem with that sometimes is that these cultures can get old, these cultures can get senescent, they can get to the point where they will in fact no longer fruit because of the fact that they've been on a single substrate for so long, have been stored for too long, or just generally haven't been allowed to go back and produce a mushroom and then from that mushroom spore out and start a new sample from that spore. So once your liquid culture mycelium, once your genetically homogeneous single individual mycelium gets tired and senescent and is no longer ready to fruit, at that point you'd need to take one of its mushrooms and go ahead and either clone directly from the mushroom itself or one of the spores. If you split the mushroom and then take a little sample of the mushroom tissue itself, that is going to be a single genetically homogeneous culture. That is going to be something that you can use to create liquid culture out of. If you were to take spores and put spores from that same mushroom down on agar or anywhere else, as a matter of fact, when they germinate, they will seek they'll seek other germinating spores, and then two will fuse, and each of the pairs that are in there will try to fuse, and you're going to end up with a bunch of genetically distinct individuals that are all fighting for control of the same media, whatever it's in, the same liquid culture media, the same substrate, the same log, whatever it's in. So that's the difference. You've got these multi-spore samples that is designed for genetic combinatorial optimization, enzymatic optimization, trying to land and produce something that's the perfect match to unlock the material and get all the energy and nutritional energy out of it. Whereas the single culture of liquid mycelium is one individual that's ready to be pushed into whatever sample you grow, and then from there go ahead and produce a nice homogeneous large batch of mushrooms that takes advantage of the fact that it's just a single individual, a fungus individual, inhabiting the entire block all to itself. That is going to produce the most mushrooms possible.